Hello friends, I am back with my series of SIP story of impressive person on the platform of igniting power engineers. I would like to start with one quote: working for success will make you master or a star. But when you start working for dissemination of knowledge or to improve something in the society, you start giving something to the society makes you legend. Legends takes no days off. Good players win races, great players breaks record, and legends change the game. And today is the second program of SIP, and we are honored and humbled and happy that I should say Maha legend, because legend is not the appropriate word for the person I'm going to invite today. Respected Honorable P. Ramachandran sir has accepted my invitation to be part of this program, a dialogue with Rajesh Arora. He's a person with more than 55 years of experience, a figure of international repute, members of SEGRE, CBIP, CA, IMA, and more. His contribution to the power sector can't be counted. Now, time to invite respected sir, and I bow my head down as a token of respect and seeks permission from respected P. Ramachandran sir to start conversation.
Thank you, Dr. Arora. Thank you for inviting me to your channel. And we will spend the next maybe half an hour or more discussing. I will try to answer to the queries that you will be raising. We'll proceed like that. Thank you once again.
Okay. Respected sir, please give me a brief description. Although I have gone through your biodata and resume, and many people have already gone through the resume. Whenever you publish some paper, they usually go through the resume or any biodata you have. But I would like to hear that story from your mouth, because that will give the motivation to many youth in the India and across world. How did you start your journey?
Yeah, I will start maybe a little with my college days. I took my engineering degree. I have only a BSc engineering, not like a BTech that most of you have, because my university, Kerala University, they were following a London University. Actually, they put up in line with the London University. I believe London University is still giving only BSc engineering. So I am only a BSc engineering, not even a BTech. This is the start. And I took my engineering degree at the age of 21. And that was a very interesting thing, probably never happened before or after also. When I joined engineering, it was a 5-year course. I had completed a 5-year primary, 6-year high school, 11, and plus 1 pre-university, 12. And after that, I had to go through 5 years for engineering. That is equal to postgraduate degree time as of today. So when I passed out, when I sought a admission for the engineering, there was no entrance or anything. They were only going by the university marks. They were selecting people, but they were demanding that when you complete the course, you should serve the government for 5 years, because at that time there was an acute shortage of engineers in India. So they said that we have to serve them. So as soon as the result was announced, even before the mark list was out, the government asked me to join a college as a lecturer near my house, and I started my journey as a lecturer teaching in the college like that. So I was there for almost 6 months. Then, of course, as all the people of those young engineers of those days, we were all so eager to join industry, and we thought we can learn a lot of things or make a lot of things. And naturally, this TELC, that is the first Indo-Japanese joint venture in India, much before than Maruti and all. It is incorporated in 1963, and with a 30% share with Hitachi. So whenever we travel over near, it was near to my house, not far away, maybe hardly 10 kilometers. So whenever we travel by in front of the road, we always see some Japanese engineers working, and all this became so exciting for me. Oh, will I be able to work with them? Will I be able to join that? Probably that is the young engineers attraction, not because of transformer or any much
At
big
that point
things.
of time, you were still working as a lecturer.
Yeah, I was working as a lecturer.
Okay.
And those days it was a lecturer's post was one grade higher than even junior engineer. So it was a
Okay.
gazetted post, no?
Okay.
Government
You
at
were
that time.
enjoying that thing.
Yeah, I was a gazetted officer. I could
Oh.
certify documents like that. But
Oh.
later in my life, I have to stand in queue in front of gazetted officers to get my certificate. Okay, no,
That gives
that is
kind of satisfaction when you have guested post with you in on your biodata. You feel
yeah. So then there was, of course, then the government order. Interesting point. That government order had the name of Mr. Madhavan Nair, who later became ISRO chairman. He was also appointed as a lecturer along with me in that same order. So the top mark, whoever got marked top marks, they were appointed like that. But
Then
soon
how
government
did
could
you
not.
enter into that telc?
No, then I was afraid, no, that bond amount was only 5,000. Still, I had that is equivalent to today's 5 lakhs. So I went to the government secretariat and pleaded with them to relieve me from the bond because I am joining another government company. Please, they approved, and that is how I joined TEL. They advertised, and I just appointed. And in December 1966, I joined TEL for a long journey of 33 years with them.
Yeah.
So their first transformer rolled out just before I joined them, 1966. I joined, and 33 years I was part and parcel of TELC. A lot of challenges and opportunities that TELC gave me. And so that was a journey, 33 years. And of course, along with transformer, TELC was making all power products, breakers, CTPT. All these were first time made by TELC, as subsystem breaker, and high voltage CTVT, all were made by TELC first time in the country. That all with Hitachi support, and they were
Sir,
good.
did you enter
Help.
that field of transformer by your own choice, or it was something the job requirement? It's a very important question. People are curious to know.
Yeah, that is also a tricky thing. If you think when I decided to join the industry, I thought I want to be only a designer or a engineering field. No, I don't want to be and all my life, frankly, I was like a paper engineer. No, fighting my battles over paper or the computer screen most of my time. Of course, I had a chance to talk almost 4 years. I was heading a division. We were making, designing and supplying substations. So I was an EPC contractor for almost 4 years. So I had an exposure all over the that type of field. So that gave me an opportunity to know other power products also, because we were designing and making those products also. But so this was my.
Sir, don't you think once you enter into an industry and you start working with a particular product, that becomes stigma that comes with your name? Even I have seen your resume after your retirement. Again, the ABB hired you as a consultant for their transformer product.
Yeah, right. Because that happened because ABB started as a greenfield project in Baroda, and they were seeking for some experienced person to help them in the technical area. So that is how I joined them on a 3-year contract to ABB in 1999. I went to Baroda. And that time also they were just making their first transformer. So in Baroda. So that 3-year contract extended almost 21 years. I was with
yes,
ABB.
I have gone through that one. That was inspiring, in fact. 21 years so after retirement is a big journey, sir.
Yeah. So that is my journey.
They just keep on extending your contract every 3 years.
Yeah. So this way, my journey was like that. So most of my time I was mainly connected with transformer. You can say even when I was the substation business, they were retaining me as the R&D chief of TELC and their QC chief also. So I was still with because I said I don't want to leave transformer. No, that is part and parcel
Yesterday
of
only I saw your that LinkedIn, uh, that article number 64 on that.
yeah, yeah, yeah.
Yes, still you are writing. Your contributions are unmatchable. It is unparalleled, in fact. Can't be expressed. Coming to a very important question, most people wanted to understand. I think you are the source of inspiration of lakhs of people. And who is your source of inspiration?
That way, if you say not a single individual, no, there were many senior engineers and even senior managers and managing directors with whom I can work, especially some Hitachi engineers. They inspired me a lot. Their hard work and their way of solving a problem, their way of documenting. All this I was immensely impressed and inspired by such working about them. And I also had
Can you
lucky to
name
work
some
with
people
some.
so that the people can
No,
understand?
all of them, most of them passed away. And of course, my writing, I sometimes write because my first managing director was one AO Woman. He was earlier chairman of Kerala State Electricity Board. But
Okay.
then after joining industry, he became a full industry man. No? And I learned a lot of things from him. And of course, he was a very senior fellow. He passed out in 1930s from London University. So as a young engineer, I had the fortunate to work with him, something like a technical assistant. No? So I could, many things which he may not tell others, I could hear from him. And so he may even correct my English, where to use shall, where to use should, and
Okay.
where to use
Okay.
will. To
Very
that
interesting.
extent, things will go.
Okay.
So my younger days, I had so many
Sir,
other
what I feel
senior.
as a young engineer, I am talking based on my experience. You have many hidden potential within you. When did you get
Yeah.
recognition of your hidden potential and that come out from you, and you get recognition of your work, and you decided that you feel happy that yes, this is a place where I want to be. When did it
I
happen?
think that maybe, of course, my bosses were recognizing my sincerity and hard work. I believe so. I had, but I openly I got that sort of a recognition is maybe almost 30 years after I joining TELC. We had a very senior managing director. He left or superannuation. He left TELC and joined some other transformer company. So after a couple of months later, he called me. And the first thing he said, Ramachandran, I never had any technical problem at TELC because it will never reach me. At your level, you will all crush it. But here I find so many technical issues, and most of my time I had to sort it out, all these problems. Then I thought that it may be a appreciation or a recognition for my effort.
And when did you publish your very first publication article, and how did you get that chance? Very important
Yeah,
for young engineers to
that
understand.
also, frankly, I was very fond of this technical literature. Of course, those days it was very difficult to get any literature because we have no internet, no document.
True.
Very, very,
Very
very difficult to get documents. So even IEEE and all, thanks to Hitachi, they will used to give us copy, and that way I could collect and read it and study the sort of thing. So frankly, all my life, I never published any highly qualified like you, doctorate level article or nothing I have written. I have all written is down to earth for fellow engineers, useful things, or my whatever I learned, I was trying to cover in my article. So
Sir,
they are
but
not very
these are
highly
more than
technical. No?
R&D people, because
Yeah,
you touch that practical things. I have gone
yeah,
through
yeah.
many of your papers, whatever I could access, all are marvelous. You it bind you to read it again and again. No option left with you after
Yeah,
reading your
so
paper.
yeah, so first time I gave a paper was there was an organization called RDOEI, Research and Development. It's a Government of India
Okay,
organization, basically for R&D of electrical products or
okay,
that R&D. It was attached with BHEL and at Bhopal. So they arranged a conference in 1971 and they asked us to give a paper. So I volunteered to give a paper, and that is how maybe just 4 years after I ventured into writing a
Out
paper.
of your many publication, what is your favorite one, and any story related to that publication would you like to share?
Yeah, my probably one which gave me maximum satisfaction on regarding the stabilizing tertiary winding in auto transformer. So
Yes,
that
yes, I was expecting the same thing,
yeah,
because
I had
that is
to
a myth
write.
among all the engineers related to. I
Yeah, yeah,
even feel
and
Tashi
it's
should be there or
already.
not, should not be there.
Yeah, so I think many engineers found it useful, and they all said that we want to ask somebody these questions, and you have answered it in like question answer way. Thank you. And it is in the internet, so I did not send to anybody. So maybe even abroad also many engineers find. So I was surprised how they found out. Then there is no, it is already in the internet. So that is my I say maximum probably people
Yes,
could
yes. If
make
you
use of
look
it.
at the internet, most people try to find your paper on tertiary requirement, and they
Yeah,
get the
right.
answer that 3 page documents is very good document. I have
Yeah,
come across. Yeah.
yeah,
Sir, coming back to your personal life again, how do you start your day and how do you get energy from?
yeah. Because I am already in the wrong side of 70s age wise. So the sleep will be less, no, at this age. So not most of the time I wake up at maybe 2 o'clock, 3 o'clock like that, and I read and write most of the writing I do at that time. Maybe till 5 o'clock or 6 o'clock. Then maybe I again go for a nap, sleep, and then that is all. Then of course I read it, write it. This is all I can do.
Okay, okay, okay. Are you doing
Yeah.
something on the social front for the
Not
contribution on?
frankly, no, not much, especially after this COVID. No, I came
Okay,
here only 1 year back. I came back to Kerala, so
okay,
not
okay.
much at.
Sir, there are many young engineers who want to know more about transformer. Apart from your blog, your LinkedIn articles, what should we read as an engineer to know more about transformer? What do you advise on that part?
Yeah, I in my blog also I have listed up many books or things. My favorite transformer book, if you ask, is by Transformer Engineering by L.F. Bloom.
Okay.
It was written by General Electric engineers in 1939 or so, and the second edition was also there. That was the best book I can recommend for engineers to understand. Of course, it was written by Americans, so little difficulty in understanding. Then, of course, I will suggest Dr. Kulkarni's textbook, also quite popular with engineers.
Yeah,
So
yeah.
today there are so
Second
many,
edition power
yeah,
engineering.
yeah,
Kulkarni sir.
yeah. Yeah, and distribution transformer, Dr. Nair has written a book last year. KRM Nair has written a book. So these are all today best books I can recommend for a young engineer to start his journey. And
Sir,
there are
are you
so many
not
other.
planning to write down a book so that young engineer
Oh,
can
I
get
don't know.
benefit of that?
Probably I am too lazy or no, not systematic. I never thought of that. Maybe one day I will collect all my blog and maybe put it in a published.
Otherwise,
So
you
that
can make compendium of all the papers you have already
yeah,
written,
that is
and
what I
that
am
can be
planning. Yeah,
published.
yeah, subject wise I can
Yes, yes, that
because I
can be
am
done.
writing subject wise, so that way I am planning maybe after 1 or 2 years later.
Coming back to your favorite subject of transformer, what do you think is the most delicate and important part of transformer? As an engineer, we should take care of that part.
Oh, that is a little difficult because each like rope, any all links should equally important. If something goes, the whole thing goes. Of course, the dielectric part is the most important part. One has to take care of other compared to other parts, and maybe a bit difficult also.
Okay, but
Of course, if you look at a transformer, there are three streams of knowledge required. One is electromagnetic area.
right.
There the losses in the stray losses, the forces, electromagnetic, the dynamic short circuit forces. These are one area. The other stream is the dielectric, where you are looking for the major insulation that is between windings or to the ground, and minor insulation, turn to turn or turn to disc to disc insulation. This is the dielectric part and how to handle all the surges and all those. That is the third part the transformer engineer has to. And the fourth is the mechanical part where the thermal engineering comes. How to the thermal and the hotspots are developed and how we can remove that heat without damaging the insulation from inside to the outside, and how economically we can dissipate it outside. So this is the mechanical part of this, and then structural part also, how to make the leak-proof transformer. So I believe these all the three parts are equally important. We cannot neglect any area. These three streams only will make a good transformer.
Okay, and according to you, what are the most common causes of failure of transformer in India? We usually hear the news of failure of transformer in many utilities in India. What do you think is the main cause, root cause of failure?
To me, the one of the major, most important item is the moisture absorption by the insulation.
Okay.
That due to lack of knowledge or other reasons, the water will enter into the transformer. A leaky transformer can also absorb a lot of water through the leak and through other reasons. And this moisture will be there inside the transformer, and it is a silent killer of transformer. It will not come out, but gradually it will impair the insulation and its insulation properties, and mechanical withstand properties also will be affected. So that is the major item that caused the aging and damage of transformer. The second part may be the short circuit forces coming on it. That mainly maybe not only transformer problem, maybe our transmission or distribution system for trees or other things coming, too many short circuit coming on the transformer. Because however strong you make a transformer, you cannot make them to withstand infinite number of short circuit. It will never. After each short circuit, its withstand capability will gradually come down. That nobody can stop that. So in addition to building very good short circuit withstand strength in the transformer, the user should also make to see that short circuit are coming as few as possible or nil. That should be, then only we will get that quality. The third aspect I would say is the quality of the bushings used. Many times the bushings explode, and that is the cause of fire in transformer and damage to the transformer. That is also third part of causing the failure. So these three areas I would say are the major problems. That is so of course both are, but here also there is one more point when we say the poor quality in transformer India and all. You know that we have the traction transformers, that is transformer put inside the locomotive and going, or the traction supply transformer coming on the side of the railway line, track side supply transformer. Yeah, I am sure none of us have ever stranded in between two substations because of the failure of a traction transformer. So we can make good quality transformer and it will never fail. Why? Because the railways have a specification. They make it thorough prototype testing, and they will not allow you to touch anything after that. Maybe next 30 or 40 years, right. The same design, everything goes like that. So standardized, so but perfectly designed, engineered, and tested prototype. And then you don't play with that, don't change anything, and run like that. And railways are super masters in maintenance, and they will keep it trim, and so it will run like that. So in India, we have very good transformers, running like that. And the track side supply transformer, the failure rate may be minimum.
To summarize in simple words, what I can understand, we have to purchase transformer with good specification. We have to look into the specification part.
Exactly.
We have to purchase as dry transformer as we can. Moisture level within winding should be as low. After erection, we have to maintain leakage. We have to attend the leakage. We should not allow that ingress of moisture into the transformer. We have to do proper condition monitoring of your transformer. And that should have proper earthing connections and other cooling system we have to take care, because cooling plays very important role. Then comes the bushing.
Right.
Sir, coming to very important and interesting part. You have been the part of many committees where you have done case studies of failure of transformer. Can you
Yeah.
give me example of very interesting study you have come across and the message learned from that particular case study investigation?
Yeah, that part, of course, the first such problem that came to my attention where my contribution was very little, but I learned a lot from that. It was done by, uh, uh, that is at that time it was not CBIP, it was Central Power Research or something like that, a slightly different organization. 1970s when the tertiary winding of auto transformers 220 by 130 11K auto transformers started failing. Of course, Telc was not involved in that, but other manufacturers had a lot of problem and a lot of study was there. And of course, Indian engineers, we could find it out why it is failing and we could prevent it and take suitable countermeasures we can take it. That was one of the earliest generic problem that was faced by power transformers and that was solved by Indian engineers. Personally, the most tricky or where I had to was pushed to the wall was something happened in 1980s. It was a 315 MVA bank actually formed out of single phase transformer and then formed it. And the tertiary we had the ground detection PTs were single phase PTs and one of the secondary you connect it to open circuit broken delta, no? And then put a relay so that you can find out some earthing happens on the tertiary side, voltage will come there and it will give an alarm to you. So we have provided that in one of the stations in Andhra Pradesh. It was for NTPC. At that time, PGCL said to come, so just to come only. So that order was executed for NTPC and our legendary Maha ji was the technical director of NTPC. And after the contract was such that we will get a major part of the money only after successful commissioning and acceptance by NTPC. And we found that there was some voltage will come there and it will give an alarm 20 volt instead of 110 or 30 volt like. So NTPC engineer said, no, some problem in the transformer. It should be zero. Why occasionally it is coming? I was really, so I sent a team of engineers to investigate. They went, we were all thinking that some earthing, some leakage of the post insulator or something must be there. That is why this leaked voltage is coming. So they measure the whole support insulator everywhere. Nothing could be found. And then I was really worried. I again went back to Maha ji, sir, there is nothing we could find and what we can do. And almost 3 crores at that time, that was a huge money for us.
Okay.
And we could not survive without that money. So please. So he said, no, you have to find it out. It must be something, your flux density. He has raised so many issues.
Okay.
So what shall I? So I again sent another team. They also came empty-handed. So I was finally pushed to the wall. I have nowhere to go. I even went to my old professor in engineering college. He also told Ramachandran, there must be something wrong somewhere. Some earthing will be there. Otherwise, how it will come? So that issue. So probably every night I was sleeping, starting thinking how I should solve it. I don't know about it.
Then how
this
did
is
you
also one. No, I solved it. The thing was, one night early morning when I woke up, I had a lightning strike. There was because when I was a trainee in Hitachi, I have used to collect. I was so fond of literature. Even today, IEEE or whoever writes something on transformer, I will try to get a copy or something. I will try to.
We can look at the library, small library at the behind
Yeah.
of yours.
Yeah. So I will.
On the
I had.
background that can be visible.
I used to pleaded with my Hitachi friends, and I got a large volume of IEEE papers. So I remembered that there was a paper there called neutral inversion. Some GE engineers written a paper. Then immediately first thing I did to the factory, I took out that old from the Almara, and then I found that they faced the same problem in 1940s in USA. And what engineers found that this is called a neutral inversion because of the
Okay.
capacitance of the, because there is no earthing, capacitance of the cables or the bus bars with the inductance of transformer cause some sing-sang sort of thing. This you can avoid. Suppose you increase the capacitance, it will disappear. Otherwise, this will create a, they called it a neutral inversion. Actually, engineers are not fully aware because this is rarely we come across such a completely
In fact, it's a new subject
unearthed,
for me.
yeah, unearthed system, no, nor because the delta is not earth anywhere. So even without earthing, it will the neutral will shift slightly. So the solution was you put we were planning some surge arresters. As soon as surge arresters were put, the problem disappeared forever.
Wow.
Another solution is you can put a small resistor across the broken delta. Then
Okay.
also it will disappear. Yeah, this is also another thing we can, yeah, we can solve this type of problem because the resistor will create some I squared R loss that will also avoid this. This fluctuation point will shift. The what you call the resonance point will shift, and this
I
neutral
think
inversion.
it is a biggest challenge before you, and you had
Yeah,
overcome it.
probably my career wise that was the biggest thing,
Biggest
and
challenge.
how I got the solution is much more worthy way.
Yes.
I still wonder how. So it is all shows that if you are pushed to the wall, some solution will come. No,
Definitely.
this is
You have
also
to keep on searching the thing solutions.
yeah,
Definitely
yeah.
you will get some solution.
So this is
Sir,
a yeah,
coming
please.
to next part, what is your future plan? Now you have come back to your Kerala, your native place.
Yeah, I don't have much big plan or anything. Of course, people sometimes come with some issues, technical issues, problems, transformers, some both manufacturers and users. Sometimes the same problem from both user and manufacturer I get now. so, so this I try to help them, try to sort it out, help. And then I, of course, as you yourself has said, I write a newsletter every weekend. I publish it.
Yes, yes.
So some 4 or 5 pages, some specific problem I take and try to be
I have
useful to
taken
the
much of
other
your
engineers.
time. I'm going
Yeah.
to the last questions of my conversation, my dialogue.
Yeah.
Can you give some advice, some suggestion for the youth engineers, learner people like me to get success in their life? But I feel if we can have only 1%, whatever you have, we can get success level that you have achieved.
Yeah, no, there this I used to, because even ABB, whenever they annual recruit a batch of maybe 100, 200 engineers, they recruit. So they will be sent to each factory. So I used to address them every year. And always last, even though it is not in the agenda, I used to advise them what you want to be. So first I will ask them, how many of you want to become the managing director of ABB? So maybe I will not find anybody raising the hand. So I said, you don't have even that ambition, no?
Yeah,
Then what
you
we
should
will
have
do?
ambition. Then only you can
Yeah,
chase your dream.
yeah. So what I always used to tell is the engineers, whatever job you are doing, whatever, this is all excuses. People say, no. I did not become the manager and director because I was put in the production line. If I were in marketing, I would have been the manager director. Or if I were engineer design, I would have been like, these are all excuses. Every field has challenges. Every field is equally good. Our job is we should try to enjoy our work. When you find you are not enjoying your work, better quit and find some other job. But the main reason why you are not enjoying your work is you don't have in-depth knowledge of the subject. If you have in-depth knowledge, every day is a challenge for you. You will not be solving problems. You will be enjoying the day. So
True.
this is a basic address I can give to the young engineers. One more point I will tell to the engineers is, we always find a person of height, say 5 feet 8 inches, normal average height of Indians men. No, somebody make even 6 feet. Oh, we say, oh, how tall he is. But remember, he is only 6% taller. No, but still we feel, oh, how tall he is.
Yes.
Our mind, my impression is like that. But a poor man, if it is only 5 feet, oh, how dwarf it is. But he is hardly 10% shorter. But still he looked, we feel, oh, poor guy, he is not tall enough. We feel like that. This is true for our work also. Are you
are
ready to put at least 5% more? 5%. It is not a big challenge or big quantity. But then everybody will say, oh, he's how tall he is.
Yeah.
This is only
The
thing.
difference
So this
between a good person and a legend is of some percentage. You have to just
that
move to
very
that
small, very small. That is the
very
point
small
I want to
difference.
impress. Yeah.
And
But the difficulty is people are not even to put that 1% extra. That is
yes,
the problem.
if you give up putting that 1% in your life, you can't become legends. And I would like to stop my conversation with one quote: heroes are remembered and legends never die. And the same thing is applicable for this living legends, respected, honored P. Ramachandran sir. Thank you once again. And I would again say you are not legend, you are Maha legend. Thank you again for accepting my invitation. And these scriptures, these are going to be scripture for youth, because I'm going to upload that thing on my YouTube channel and social media, so that many people are going to get benefit of that thing across globe. Thank you once again. Thank you.
Thank you,
And I
Arora.
bow my
Thank
head
you.
down again. Thank you.
Thank you. Thank you.
Thank you for your blessings.
Thank you.